Hey guys, this is JB from Planning C Tutoring. In this video, we're going to be talking about exponential rules. There are a few of them. We got the product rule, the quotient rule, the power rule, the zero rule, which it goes hand in hand with the identity rule, the rule about negative exponents, and fractional exponents. Don't forget to use your referral code JBMon20 to get 10% off on your next tutoring package. Alright, let's dive right in. So just to start off, what these rules just say is whenever you're multiplying two different numbers where the bases are the same but you have different exponents, maybe let's say maybe like a to the power of b times a to the power of c, you just add up the exponents to find what the answer is. So this would become a to the power of b plus c. Note they have to be the same exact base, and that's going to be a rule for all of them here. For the quotient rule, anytime that you're dividing this time, it's going to be the exact opposite. A to the power of b, a to the power of b divided by a to the power of c, which remember this can also be written as a fraction, a to the power of b over a to the power of c, is equal to a to the power of b minus c. Now the power rule has to deal with whenever you take a number to a power and then take that entire number to an extra power. So let's say you have a to the power of b, then you take this whole number to the power of c. This is equal to a to the power of b times c. It's the same as multiplying b and c together. The zero rule is more so an identity type rule where any number taken to the power of 0, a to the power of 0, any number is always going to equal 1. Regardless of what number it is that you take, any number taken to the power of 0 is always going to equal 1. In addition, any number taken to the power of 1 will always equal itself. That would be the identity rule. The zero and the identity rules kind of go hand in hand. Next we have negative exponents. Whenever we have negative exponents, let's say a to the power of negative b right here. That's the same as doing 1 over a to the power of b. So if that was like a to the power of negative 4, that would have been 1 over a to the power of 4. It's the same as doing it inverse. Finally, fractional exponents. Let's say a to the power of b divided by c, b over c. Well, that's the same thing as taking the root of something. So this would be the cth root of a to the power of b, which is also the same thing as saying the square root of, or the cth root of a taken to the power of b. Both of those are identical. Alright, let's try doing a couple of practice problems. With respect to the product rule, let's try doing maybe something like 2 to the power of 3 times 2 to the power of 4. To do a problem like this, you're just going to be, since the bases are the same, you just add up the powers, and you get 2 to the power of 3 plus 4, which is equal to 2 to the power of 7. And you can see this is true because you're just multiplying 2 times 2 times 2. It's 2 to the power of 3. Times 2 times 2 times 2 times 2. Well, obviously that's the same thing as 6, 7. Let's make this one a little bit harder. Maybe let's say that we were working with x cubed y squared times x y cubed. Well, this right here, only the x's can multiply with one another, and x to the power of, well, no number in front of it is the same thing as x to the power of 1 because of that identity rule. because of this identity rule right here. So we can technically just fix this up by adding a 1 right there. And now we get x to the power of 3 times x to the power of 1. Well, that's just x to the power of 4. Then you get y to the power of 2 times y to the power of 3, which is y to the power of 5. Let's try the quotient rule now. With the quotient rule, let's do x to the power of 5, y to the power of 2, over x to the power of 4 and y. Well, the 5 and the 4 cancels to get an x, or x to the power of 1. And the y squared and the y to the power of 1 cancel to get you just y. Both on the numerator. But yep. If we were to do another one, maybe let's say we did 3 to the power of 2 over 3 to the power of 5. Well, 2 minus 5, that is 3 to the power of negative 3. Well, I know that's the same thing as 3 to the power 1 over 3 to the power of 3, which is 1 over 27. Let's try the third rule. With the third rule, we have a power rule. So if I were to do maybe, let's say I were to go with c to the power of 3, well, that's just going to be c to the power of 2 times 3, which is c to the power of 6. And we can expand this a little bit further. Maybe we want to work with maybe a fraction, x squared over y to the power of, let's say, 2. Well, this is the same thing as saying x squared taken to the power of 2 over y squared, which gets me x to the power of 4 over y squared. That we can keep making this as complex as we want. We can work with like numbers and problems. Say 4xy cubed over 12x squared y cubed power of 2. Well, this is going to get me 4 cubed, which is 64. X cubed, y cubed over 144 x to the power of 4, y to the power of 6. That cancels, and you're left with, and you can simplify the 64 over 144. Which in turn leads to being what is this? Divide both by, I think the smallest common factor here is 16. 4 divided by 16 and 144 divided by 16, which gets me 4 over 9. X is on the bottom, y is on the bottom, and we have 3 y's, or y cubed on the bottom. Because 3 minus 4 is going to be x to the power of -1. y3, y6, that's going to get you y negative 3, which is a y cubed on the bottom. All right, the fourth rule encompasses just the 0 rule itself. Any number, whether that be 36 to the power of 0, you're going to be getting 0. Now, the only exception to this rule is the fact that 0 to the power of any number, 0 to the power of a, should always equal 0. The only exception to both of these rules is 0 to the power of 0. Because for the first rule, if we follow that first rule, then that means this should equal 1. If we follow the second rule, though, then that means this should equal 0. And 1 and 0 are not equal to one another, so that kind of breaks everything. That's why we kind of exclude 0. The fifth rule, we have negative exponents. And we kind of already worked with a few of these negative exponents, but let's just try and look at maybe a couple more. Let's say we have 4 to the power of negative 3. Well, that's the same thing as 1 over 4 cubed, which is 1 over 64. How about a to the power of negative 3 b squared over c to the negative first d to the power of negative 2. Well, if I combine my terms appropriately, well, I can rewrite this as c b squared d squared over a cubed. And in fact, that's actually the simplified version here. Finally, I can go down to number 6. Sixth rule is just fractional exponents. And so if I were to do something like 7 to the power of 2/3, well, that's equal to the cube root of 7 taken to the power of 2, which is also the same thing as 7 squared taken to the power of, or taken to the cube root power, or we're taking the cube root of 7 squared, the cube root of 49. We can combine all these rules here into a matter of like a couple of problems. Let's say we were working with the problem negative 2a squared b cubed c over c to the power of 0 a cubed. Let's go with a cubed b squared, and on the denominator my number is going to be, let's say, a 14. Well, the 2 and the 14, or actually let me take bottom to the power of 3. The 2 and the 14, they start canceling each other out, and you get 1 over 7, negative 1/7. A squared, well, if I take a cubed to the power of 3, I get a to the power of 9, b 6, and still z to the power of 0. 2 minus 9, that's going to get me an a to the power of negative 7. 3 minus 6, that's b to the power of negative 3. 1 minus 0, that's still 1. Leaving me with just c over a to the power of 7 b cubed times 7. And we would work this out just like this for almost every single exponential kind of problem. All right, thanks for watching. I hope you guys learned something new. That's going to be it for this video, and I'll see you guys in the next one.